Hello everyone, my name is Greg and today I prepared for you 5 questions from latest GNAV exam seen in the last 30 days across all authorities. Topic for today is basics of navigation. So question number 1. An aircraft is flying from Channel VOR to Dublin VOR, which are 104 nautical miles apart. At 10:09, the aircraft is 25 nautical miles from Channel VOR. At 10:24, the aircraft is 41 nautical miles from Dublin VOR. What is its average ground speed during the period of time between 10:09 and 10:24? 142 knots, 152 knots, 162 knots, or 172 knots. Okay, so first we need to find a distance that aircraft in question traveled between 10:09 and 10:24. Both VORs are 104 miles apart, and at 10:09, the aircraft was 25 miles outbound Channel VOR. So there was 79 miles left to the Dublin VOR. And at 10:24, the aircraft has only 41 nautical miles left. So 79 minus 41 gives us 38 nautical miles traveled in 15 minutes. Since knot is a unit describing nautical miles per hour, only thing left is to multiply 38 times 4, and the result is 152 knots. Having a distance and time, we could also solve these questions by finding a speed factor. So a distance flown in 1 minute. Here, 38 nautical miles divided by 15 minutes would give us a speed factor of 2.53333 nautical mile per minute. Then we would have to multiply it by 60 to get the speed in knots. Alright, so correct answer is answer number 2, 152 knots. And we're going to question number 2. Given the following information, what is the variation? True track, 180 degrees, drift, 8 degrees right, compass heading, 195 degrees, and deviation, -2 degrees. In navigation, we have 3 basic references when we talk about the north. The first one is the true north, that refers to a geographical North Pole. The second one is the magnetic north, where the magnetic dip equals 90 degrees. So in other words, Earth's magnetic field points vertically downwards. And the last one is a compass north. Compass indications are influenced by local factors like metal parts of the aircraft or electrical equipment. So we also have to compensate for that. Now, the difference between compass north and magnetic north is called a compass deviation, and the difference between magnetic north and true north is called magnetic variation. There's a very nice mnemonic that I like to use, namely Cadbury Dairy Milk Very Tasty, CDMVT. So compass heading, deviation, magnetic heading, variation, and true heading. In flight, we have to also include the influence of the wind, since only with pure headwind or tailwind, our heading would match the track. And the difference between heading and track we call a drift. Now, last important thing to remember is that whenever we talk about positive right or east deviation or variation, we'll be adding these values in our CDMVT equation. Opposite will be with left, negative, or west variation and deviation. Same will apply to right and left drift. If you can, I would recommend you to make now a small table and write down on the paper CDMVT and below each letter the appropriate value. So compass heading is 195 degrees, deviation -2, so the magnetic heading will be 193 degrees. Now we have to go backwards because we need to find a true heading, the last item in the CDMVT. We have a right drift, so true heading that we are looking for, plus 80 degrees of drift equals 180 degrees of true track. Therefore, true heading will be 172 degrees. And now we can calculate the variation. Since magnetic heading is 193 degrees, true heading 172 degrees, we see the difference between magnetic and true heading is minus 21 degrees. So the correct answer is answer number 1, 21 degrees west. And this one is correct. And we are moving to question number 3. Given the following information, what is a suitable altitude for turning the final? Distance to the threshold 4 nautical miles, threshold elevation 700 feet, approach angle 3 degrees. And options are 500 feet, 1,900 feet, 3,000 feet, 1,200 feet. This question we can solve using 1:60 rule. It's a very useful approximation whenever we are dealing with a relation between height and distance, or between a ground speed and rate of descent for a given angle or gradient. So here we'll be solving an equation where on the left side we have a number of degrees over 60, and on the right side we have height over distance. Since we have to use the same units, therefore to have distance in feet, we will multiply the distance by 6,080. Now, if we rearrange this equation, height will equal to number of degrees times distance in miles times 6,080 over 60. At this point, let's simplify 6,080 over 60 to 100. This is the whole equation, and approximation, it's more than enough. And now, finally, we got an equation where height in feet equals degrees times distance in miles times 100. So if we put the numbers from the question, we'll have 3 degrees times 4 nautical miles times 100, and the result is 1,200 feet height. Since we are being asked for altitude, do not forget to add 700 feet of elevation. So the correct answer is 1,900 feet altitude. Whenever you have some calculations to do, I would highly recommend you to always write everything down and not to do it mentally. We can avoid simple mistakes, and especially at the beginning, it really helps with understanding the problem. So, answer number 2, 1,900 feet, is correct. Question number 4. An aircraft is flying a 3 degrees glide path and experiences a reduction in ground speed from 150 knots at the outer marker to 120 knots over the threshold. The effect of the change in ground speed on the aircraft's rate of descent will be a decrease of approximately 50, 100, 250, or 150 feet per minute. Alright, so for a rate of descent on 3 degrees glide slope, we have a very nice rule of thumb, where rate of descent equals 5 times ground speed. You can also divide the first two numbers of ground speed, so hundreds and tens, by 2 and multiply by 100, whatever works better for you. This is one of the most useful rules of thumb that you will probably use every single day. So here, in this question, we have to find how much the rate of descent will decrease if our our ground speed will drop from 150 knots to 120 knots. So at outer marker with 150 knots ground speed, our rate of descent will be 750 feet per minute. First two numbers, so 15 I divided by 2 and multiplied by 100. At threshold with 120 knots ground speed, our rate of descent will be 600 feet per minute. So the correct answer will be answer number 4. The rate of descent will decrease of approximately 150 feet per minute. And answer number 4 is correct. Question number 5. Referring to distance units, a ratio of 1 to 1.852 is the ratio between kilometers and statute miles, statute miles and kilometers, kilometers and nautical miles and kilometers. Okay, this one is quite straightforward. It's nautical miles to kilometers conversion, where 1 nautical mile equals to 1,852 meters. In aviation, there are a few conversions that we use on everyday basis. In navigation, it's worth to remember that, for example, 1 meter equals 3.28 feet, 1 nautical mile is 6,076 feet, or the example from this question, 1 nautical mile equals to 1,852 meters. For in-flight mental math, we can use approximations that works pretty nice. For example, if we would like to find out how high we are in meters, we can take our altitude, let's say 4,500 feet, divided by 3 and subtract 10%. Our result will be 1,350 meters, which is close enough to arithmetical result of 1,371.95 meters. The same we can do in case of nautical miles to kilometer conversion. Knowing our distance in nautical miles, we'll multiply it by 2 and subtract 10%. So, answer number 4, a ratio of 1 to 1.852 is the ratio between nautical miles and kilometers. And this is the correct answer. All right. Thank you very much for today. I hope you enjoy, and see you next time.